Welcome back. In this video, we can discuss about Armstrong's axioms. These axioms are actually used for inferring various functional dependencies in a given relation. So this Armstrong axioms is a set of rules actually. These rules are used for inferring various functional dependencies on a given relational database. We have 6 such rules like reflexive rule, augmentation rule, transitive rule, union or additive rule, decomposition or projective rule, and finally pseudo-transitive rule. The first 3 is considered as primary axioms and the remaining 3 are derived based on the primary axioms, so they are called secondary rules. We can consider each and every these rules in detail. So first is about the reflexive rule. If A is a set of attributes and B is another set of attributes in a given relation R is a relation which is given, consider 2 sets of attributes in that relation R, like A set and another set B. And one more condition, if this set B is a subset of A, then this particular functional dependency holds there. That means A derives B if B is a subset of A. Okay, consider one example. Employee table with attribute like E number, E name, salary and city. Consider 2 sets like E number, E name as the first set and another set with E name alone. From this it is clear that this one is a subset of this set. Okay, that means if we know the E number and E name, then we can directly say the number is 1 and the name is Smith. Okay, suppose the number and E name is given as 1 and Smith, then from that given information we can directly identify the number as 1 and name as Smith. Okay, that is the meaning of this reflexive rule. So using these 2 set of attributes, this particular functional dependency exists here. If we know the number and name, then we can define a functional dependency to another set E name. Similarly, E number, E name to E number. Okay. Next is about the augmentation rule. Okay, here also consider a relation which is given as R, in which consider 3 sets like X, Y and Z. Okay, and the condition is if X implies Y is a valid functional dependency here, then X and Z together derives another attribute value, that is Y and Z. If X derives Y or X determines Y is a valid functional dependency, then X and Z derives Y and Z is also valid here. Okay, this augmentation rule is also called partial dependency. So from this example, the same relation employee with the same set of attributes. Okay, consider the sets like X, the first set with E number, second set with salary and third set with E name. And suppose E number derives salary. This is a valid dependency here. That means if we know the number, we can directly identify the salary of that particular employee. Okay, then attach the third set to with these 2. If E number implies salary is a valid dependency, then E number comma E name implies salary comma E name is still valid. If this is a valid dependency, then this also a valid dependency. That means if we know the number and name, we can say the salary and name of that employee. Okay. Third one is the transitive rule. This is already this was already discussed in our previous video, like transitive dependency. The same rule is used here for this particular axiom, that is transitive rule. If x, y and z are three different sets of a given relation R, x, y and z are three different attribute sets of a given relation R, then if x implies y is a valid dependency and y implies z is another valid dependency, then x implies z is also valid. This is transitive rule. X implies y, x derives y and y derives z are two valid dependency in a given relation. Then x implies z is also valid there. Or we can infer another dependency with the help of these two. Okay. The same example. Suppose this e number derives the name e name as a valid dependency. Here it is valid actually. If we know the number e number, then we can directly identify the name of employee. And similarly, if we know the name, then we can identify the city in which that particular employee is living. So, e-name implies city is another valid dependency. If these two are two valid dependency in this given relation, then e-number implies city is also valid here. That means using these two valid dependency, we can infer the third dependency, which is not given here, but this is still existing there with the help of these two valid dependencies. That means if we know the number, we can identify the name. If we know the name, then we can get the city in which that employee is living. From these two, it is clear that if we know the number, we can get the city in which that particular employee is living with the help of this name. Okay. This is about transitive rule. Next one is about the union or additive rule. This is simply an addition of different dependencies. That means x, y and z are three different set of attributes in a given relation R. If x implies y is a valid dependency in the given relation, x implies z is again a valid dependency, then x implies both y and z. These two functional dependency get added together to form a single dependency. X implies y and x implies z is valid, then x implies y and z is valid. Okay, that means using these two, we can infer this particular dependency with the help of this union or additive rule. Consider the example. E number implies e name is a valid dependency in this table. E number implies city is again a valid dependency. That means if we know the number, we can identify the name of employee. Similarly, if we know the number, we can directly identify the city in which that employee is living. From these two, we can apply this additive rule. After applying this additive rule, we can infer another dependency which is again valid here. That means E number implies E name, city. With the help of this E number, we can identify both E name and city. Right? So, using this additive rule, we can infer this particular dependency with the help of these two given valid dependencies. Okay? And the fifth one is about decomposition or projective rule. It is just the reverse of our previous additive or union rule. This rule says if x determines x determines both y and z, then x determines y and x determines z separately. Just the reverse of our additive rule. If x determines y and z, this is a valid dependency in our given relation, which is given. If this particular dependency exists, then we can infer these two dependencies separately, like x implies y and x implies z. If this one exists, then we can separately infer these two dependency here with the help of this decomposition rule. Consider one example. And if e-number implies e-name, comma, city, this is a valid dependency which is given here. Then from this we can infer two separate dependency, that is e-number implies e-name. This is again a valid dependency. And e-number implies city is still valid because this particular dependency is valid here. So with the help of this decomposition rule, we can infer two other dependencies like these two. They are also valid here. Okay. And finally, we have the pseudo-transitive rule. Okay. This pseudo-transitive rule identifies a relation like this. For that, we consider different sets like x, y, z and w. Okay, if x determines y, all these are set of attributes, right? X, y, z, w all are set of attributes in a given relation R, right? Then if x implies y and y, z implies w, these two are valid dependency which are given. Then we can infer another dependency, that is x and z determines w. X implies y and y, z implies w. These two are the valid dependency given. Then x, z implies w is again a valid dependency which is inferred from these two given set of dependency with the help of this transitive rule. Consider one example. Employee table with two more attributes, e-number, e-name, salary, city, date of birth and age. Okay, so e-number implies e-name as a valid dependency given. That means if we know the number of our employee, then we can identify directly its name, which is given valid dependency. Another dependency like e-name, comma, date of birth derives age of the employee. If we know the name and date of birth of our employee, then we can derive his or her age. This is also another valid dependency which is given. If these two dependencies are given, these two valid dependencies are given, then we can infer another dependency. From these two valid dependency, we can infer another dependencies like e-number, date of birth derives the age of employee. Okay, with the help of this pseudo-transitive rule, if these two dependencies are given, then we can infer this third dependency here. This is also valid here. Okay, suppose the number is given as 1. From this, with the help of this, we can identify the name of employee as Smith. Okay, e-name, date of birth. That means you are given with name and date of birth. Okay, we know the name like Smith and date of birth of Smith. Using this information, we can derive the current age of the employee. Okay, so these two are available. Then we can identify or we can define or we can infer our third dependency with the help of this pseudo-transitive rule. That is e-number, date of birth derive our age. If we know the number of our employee and the date of birth, it derives the age of that employee. Okay, so this is about our pseudo-transitive rule. So these 6 are different Armstrong's axioms. These are used for inferring various functional dependencies, valid functional dependencies with the help of given set of dependencies in a given relation. Okay, thank you.